Alright, for question number 6, January 2025. The curve C has equation y is equal to f of x. We're given P's coordinates. We're told that the gradient of the tangent to C at P is 7, and we are given the gradient function. Show that 4a plus b is 24. So if the first question is a show that question, we know that we just have to use the facts that we've been given to solve and prove. So if the gradient of the tangent to C at P is 7, we know that P's x-coordinate is 4. So if we were to substitute that into the dy by dx, this is f dash x. If we were to equate that with P's x, which is 4, we would get 7. So you just substitute 4 for x in here, and you should get 7. So we just write that 4 squared plus 4a plus b over 4 root 4 should give us 7. 2 times 4 squared had to put that in my calculator. 32 plus 4a plus b. Move the denominator to the other side. 7 times 4 root 4 be equal to 56. Just move this to the other side. 56 minus 32, and we get 4a plus b is equal to 24. Hence proved. It's not a proven question, just nice to write. Right. In the next part, given also that a plus b is equal to minus 9, find in its simplest form f of x. These types of questions for 7 marks, they're quite common, where you're given the gradient function and you're asked to solve for f of x, the original function. It's just important to know that generally with these types of steps, you have to integrate the dy by dx, and then use a point that you've already have, like they usually give it. Over here we have P's coordinates, to solve for C, and then rewrite the entire f of x. The only extra step in this question is solving for a and b. So we already know that 4a plus b is equal to 24, and we've been given a new equation that a plus b is equal to minus 9. This is a linear simultaneous equation, so I'm just going to subtract both of them. 4a minus a, 3a, b minus b is 0, 20 minus b is 0, 24 minus 9, 2 negatives make a positive, we get 33. So a is equal to 33 over 3, which should give us 11. And then we just use any equation that we already have. Let's just use this one. So minus 9 minus a should give me b. Minus 9 minus 11, we get minus 20. So b is equal to minus 20. And then we rewrite the gradient function. F dash x should be 2x squared plus 11x minus 20 over 4 root 4. That's our gradient function, and then we have to integrate it. It's 4 root x. We do have to rewrite this so that it is easy for us to integrate it. So first of all, what I'm going to do is just rewrite the denominator as 4x to half, and we have to divide each term by the denominator. So 2x squared over 4x to half. So 2 over 4, that's 1 by 2. 2 minus a half, that's 3 by 2. Plus 11 over 4x, 1 minus a half is a half. Minus 20 divided by 4, that's minus 5. Minus 5x, a negative half. Feel free to write each division thing like separately. If it makes it easier for you, it's perfectly all right. So this is our gradient function, and now we do have to integrate it. And we have to remember, if you want to integrate x to the power n, it becomes x n plus 1 over n plus 1 plus c. Don't forget the c. Right, so a half x 3 by 2, 5 over 2 over 5 by 2 plus 11 by 4x 3 by 2 over 3 by 2 minus 5x, negative a half becomes a half, plus c, and now it's just solving it. I prefer writing it this way. You can solve it any way you wish. 1 by 5x 5 by 2 plus 11 by 6x 3 by 2 minus 10x a half plus c. All right, so this is our f of x, sorry, just f of x, and now we have to solve for c. How do we solve for c? We use our p coordinates. We know that p's coordinates are 4 and minus 5. So that means f of 4 should give us minus 5. So what we're going to want to do is substitute 4 over here. So it's important for your marks to just write it down. It all into my calculator. I've solved it to be 16 over 15 plus c is equal to minus 5. So we just, c has got to be equal to minus 5 minus 16 over 15. Hence, c is equal to minus 91 over 15. You feel free to plug it into your calculator one more time just to recheck. So our final f of x is equal to 1 by 5x 5 by 2 plus 11 over 6x 3 by 2 minus 10x to the power half minus 91 over 15. There we go. For our final question, curve C is transformed to the curve with equation y is equal to f of x minus 3, given that the point P is transformed to the point Q. All right, so how does this work? If we have f of x, and f of x has the coordinates x and y, if it's transformed into f of x minus 3, we need to remember, for graph transformations, whenever it's inside the bracket, it affects x in the opposite way. So this really becomes x plus 3 and y stays the same. So if our p's coordinates were 4 and minus 5, over here we have to do 4 plus 3 and minus 5 stays the same. 4 plus 3, that's 7 and minus 5. Hence q's coordinates are 7 and minus 5.